everyone, this is Ma'am Pascual. Welcome to my science class. To start with, let's play a crossword puzzle. You can pause the video to answer the questions. The key terms in this crossword puzzle is that you are able to review the different terms you have learned from your previous lesson, which will be useful in our lesson. By the end of this lesson, you are able to locate the epicenter of the earthquake using triangulation method, describe the distribution of active volcanoes, earthquake epicenters, and major mountain belts, and determine the scientific basis for dividing the lithospheric plates. So, tara! Now, let's find the earthquake epicenter. Here are the requirements. First, you need to have a minimum of 3 seismic stations. You need to know the lag time or time difference of the arrival of P waves and S wave. Third, to compute for the distance of the epicenter from the seismic station, so you need to use the formula distance is equal to time difference over 8 seconds times 100 kilometer. And then using the computed data, make a circle surrounding the seismic station. Let's try the 3 stations in Baguio, Iligan, and Puerto Princesa. In Baguio station, if P waves arrive 5 seconds and S waves arrive 32 seconds, what is the time difference? The time difference is 27 seconds. To get 27 seconds, you need to subtract the S wave minus P wave. Thus, 32 seconds minus 5 seconds, so you will get 27 seconds. This time, we will find the distance of the epicenter from the seismic station. So, the answer here is 337.5 kilometer. So, to get that, we will use the formula distance is equal to time difference over 8 seconds times 100 kilometer. Therefore, 27 seconds divided by 8 seconds times 100 kilometer, your answer is 337.5 kilometer. Now, let's try computing the scale. If there is 1.5 centimeter for every 200 kilometer. The answer here is 2.53 centimeter. To get that, so we have 337.5 kilometer times 1.5 centimeter over 200 kilometer. So you will get 2.53 centimeter. Now let's try Tacloban. In Tacloban Station, the P waves arrive 3 seconds and the S wave arrive 28 seconds. What is the time difference? What is the distance of the epicenter from the seismic station? And what is the computed scale using 1.5 centimeter for every 200 kilometer? You can pause this video to answer. If your answer is 25 seconds for the time difference, 225 kilometer for the distance of the epicenter from the seismic station, and the scale of 1.68 centimeter, your answer is correct. Now, let's try Puerto Princesa. In Puerto Princesa station, the P waves arrive 6 seconds and the S wave arrives 47 seconds. What is the time difference? What is the distance of the epicenter from the seismic station? What is the computed scale? using a scale of 1.5 centimeter for every 200 kilometer. You can pause this video to answer. If your answer is 53 seconds for the time difference, 662.5 kilometer for the distance of the epicenter from the seismic station, and 4.9 centimeter for the scale, your answer is correct. Congratulations! Now, this time, the computed data that you got, will be plotted on the map. So we will use the station Baguio, Tacloban, and Puerto Princesa. For Baguio, which has a distance of 337.5 kilometers, it means that 337.5 kilometers is the distance of the epicenter from the seismic station. We just don't know the exact direction of the epicenter. That's why we are making a circle surrounding the seismic station, particularly Baguio. So, the 337.5 kilometers will be the radius of the station. Then, to be able us to plot this in our map, we will use the scale 1.5 centimeter for every 200 kilometer. Therefore, 337.5 kilometer is equivalent to 2.53 centimeter, as shown in the picture. So as you can see, 2.53 centimeter is the radius of the circle surrounding the entire Baguio station. Then we will do in Tacloban. We will do the same with Tacloban with a distance of 225 kilometer, which is equivalent to 1.68 centimeter. So this is the pictures of the circle surrounding the Tacloban. Lastly, the Palawan, which has 662 kilometer, which is equivalent to 4.9 centimeter. This is how we plot it in Palawan. Okay, under Puerto Princesa Station. The intersections of line means that is the location of the epicenter. Again, the lines of intersection of the three circles means that is the area of the epicenter. The Sibuyan Sea is the location of the epicenter based on the map. Let us now proceed to the distribution of earthquake epicenter, volcanoes, and mountain ranges. Now, let us observe the four maps. The first map is a map of the earthquake epicenter in the world. The red dots are the earthquake epicenters. Look at the Pacific Plate, the South and North America, as well as the Africa and Australia. It seems that the red dots follow a certain pattern. This is the second map of major volcanoes, seen in red highlight. As we can see here, most of the volcanoes are found along the Pacific Ocean. That's why it is also called the Pacific Ring of Fire. This is the third map of the mountain ranges in the world. Look at North America, South America, which is beside the Pacific Ocean or Pacific Plate. This is the fourth map, the map of plate boundaries. It divides the plate into several segments, as well the type of plate boundary present in a certain plate. Look at the structure or pattern of Pacific Plate and North and South America as well as Australia. Let us compare the four maps. Let us observe the location of earthquake epicenter, volcanoes, mountain ranges, and plate boundaries. Based on this illustration, mountain ranges are found in places where volcanoes and or earthquake epicenter are also located. They are mostly found near the edges along narrow zone. So we can conclude that since the plate are in constant motion, they interact along their margins. So important geological processes takes place such as the formation of mountain belts, earthquakes, and volcanoes. This is also the basis of the scientists in dividing the Earth lithosphere into several plates. Their bases are based on the geologic activities such as seismicity, occurrence of earthquake, volcanism, and mountain ranges. So now let us test your understanding. Let us have a quiz.
Question: what are the basis of the scientist in dividing the lithospheric plate into several segments? Option 1. The location of earthquake epicenter. Option 2. Location of mountain ranges. Option 3. The location of volcanoes. Option 4. All of the above. Question: from the seismogram, the distance to the epicenter can be determined by measuring. Option 1. The difference in the arrival times of the P and S waves. Option 2. The speed of the surface wave. Option 3. The arrival time of surface wave. Question: due to plate movement, earthquake, volcanoes, and mountain formation are the geologic processes/features/events that are created. Option 1. False. Option 2. True. Question: if P wave arrives 12 seconds and S wave arrives 34 seconds, what will be the distance of the earthquake epicenter from the seismic station? Option 1. 22 seconds. Option 2. 275 seconds. Option 3. 22 kilometers. Option 4. 275 kilometers. Question: you were provided with data showing the arrival time of the P and S waves recorded from 3 seismic stations. Which of these can you possibly determine? Option 1. The location of the epicenter. Option 2. The intensity of the earthquake. Option 3. The distance to the earthquake. Option 4. The damage at the focus.
This ends our lesson for today. I hope you enjoy and learn. Goodbye and God bless.